Hi guys, in this video we are going to discuss the daily lead code challenge for 7th of January. The problem's name is gas station. This is a good problem, I'll say. So I've seen this problem coming in a lot of interviews. So this is one of the most favorite problems for companies. Also, this is not exactly a easy to meet a medium level problem. It's somewhere in the medium to hard range. So with that, let's get started. So the problem states that they are in gas stations along a circular route where the amount of the gas in the ith station is gas I. You have a car with an unlimited gas tank and it costs cost I of gas to travel from the ith station to the next I plus 1 station. You begin the journey with an empty tank at any of the one gas stations. Given two integer array, gas and cost, return the starting gas station's index if you can travel along the circuit once in the clockwise direction, or otherwise return -1. If there exists a solution, it is guaranteed to be unique. Then they have provided us with a lot of examples, or just two examples over here. Cool. So with that, let's get started. So let's say this is the gas tank. Let me draw with a different pencil. This doesn't look nice. Okay. So this is the gas tank, and this is the cost tank. And this my car. This is my car. I know it doesn't look great, but that's how my car is. So yeah, I'll pick up my car. I'll place it at a gas station. So whatever gas station it starts with, it doesn't have to fulfill the cost for that, right? So if it's starting at 3, initially it has the entire gas of 3. If it is starting at this particular point, then it has the gas of 4. So with that, I can start with any gas station. So let me say that I start with any gas station, let it be 3 as of now. So if I'm at 3, the cost of reaching the next index is 5. So the value you just see below it is the cost you require if you want to travel to the next gas station. Are you able to do it? So no, because the current gas you have at 3 or at the index. Okay, so let's just mark the indices for more clarity. So let's say this is okay, that doesn't work. Right, 0 1 2 3 4. So at index 2 the gas you can have is 3, and then you need a total of 5 steps or a total of 5 fuel to get to the next point. So can you get over that? No, because 5 is greater than 3. You don't have sufficient fuel, so you can't do that. So let's pick our car up, get to the other location. So if I'm at 4, can I do that? Yeah, it makes sense actually. So if I'm at 4, the if I'm at the index 3, I meant. So if I'm at index 3, I have a gas of 4, right? So let's say this is my gas. Let's draw that with green. Okay, so the gas I'm having is 5 units or 4 units. The gas I require to travel to the next index is actually only a single unit. So I can travel to the next index and I'll still be having a gas of 1 unit. Perfect. Cool. So now my car is at 5. Perfect. So when I'm at this particular index, that is the index 4, I can fuel up my car with 5 more units of petrol or gas. Okay, so plus 5. Now you have a total gas of, so over here I had a gas of 4, I subtracted 1, it was actually 3. So over here you now got 5 more units of gas, so you have a total of 8 gas. Great. And now I have a total I have a total of 8 gas points in my fuel tank. And what's the amount I require to travel to the next point? I just require 2 units. So from with 2 units I can go from this point till this point. Okay, great. So with 2 units I go from that point to this to the another point. So let's subtract 2 from here as well. Now the answer I'm having is 6. So with that, my car travels in the circular direction that as they mentioned. I go all around over here. I come to the first or the 0th block. Then over here I check. Over here I can actually fuel up my car more with 1 ounce of or 1 unit of gas. Now I have 7 gas in total. The amount of gas I require to go to the next point is actually just 3 units. So yeah, I have more gas than required. So yeah, I can subtract 3 units from it. I'll still have 4 units of gas, and I can start going to the next point. So now I'm at 2. Also, do you remember where we started at? So we actually had started at the third index itself. So this was the start. So what we want is that we want to reach the third index back. Great. So now I'm at 2. I can refuel with 2 units of gas. I'll add 2 to this. Now I have 6 units of gas. Perfect. So Now I have 6 units of gas. In order to go to the next point, I need 4 units of gas. Can I utilize that? Definitely. If I have more gas than I need, I can use that. So now I'll utilize 4 units of gas, subtract 4 from here. I'll now have 2 units of gas left with me, and I'll be standing at this point, at point 3. Okay, so that didn't work. Give me a second. Cool. So now I'm at point 3. At point 3, I can refuel with 2 more units of fuel. So over here, I have 2 more units of fuel. I can fuel it up with 2. Okay, I messed up somewhere because that's not working. So I definitely messed up somewhere. I really don't know where. Let me see. Where did I mess up? So I subtracted 4. I got it 2. So okay. So initially I had 3. I started there. I had 5. I had actually 4. Then I subtracted 1 from it. I had 3. Then I added 5 to it. I had 8. That makes sense. Then I subtracted 2. I had 6. Then I again invented. I added 1. I have 7. I utilized 3. I have 4. Okay, I added 2. I have 6. Utilized 4. Okay, got it. Yeah, so at point 2 itself, you actually have 3 units of gas available, right? So when you'll add 2 and 3, you'll get 5. Okay, so at this point now you have 5 units of gas with you. So what's the amount required to travel to the next point? It's exactly 5 units of gas. So can you do that? Yeah, you have the required fuel. So now I'll say, apologies for this. Okay, so now I'll say let's travel to the next point. So I'll pick up my car, or the car will pick me up, and it will drop me to the next point. So voila, we reached the point we wanted to. So this was the index we started at, and we were able to reach the same index back. So does that complete our travel or our circular loop? Yes, it does. So we can return now 3. So let's see what's the answer they are returning. So yeah, they are also returning 3. But now the point is, how can we do that? So one naive approach is that for every point I can check this. So I can start my car from 1, I can start my car from 2, from 3, from 4, until and unless I can find a valid loop. I can keep doing on it. What would be the complexity for that? So the auxiliary space complexity would still be order of 1, so that's not a problem. However, the the time complexity would be order of n into n, because for all the n points we are trying this particular traversal. So it would be order of n into n, order of n square. Definitely a TLE, because if we look at the constraints, so the constraints are n is less than or equal to 10 to the power 5. So if you are having n is less than or equal to 10 to the power 5, n square is going to give you a TLE. N log n might work or would work, but n square won't. So what could be a solution? So what I can say is that let me start at any index for that matter, right? I can start at index 0 or at index 1 or at index 2, 3, 4, whatever I like. Let me try to traverse, right? If I'm unable to traverse, what I'll do is I'll pull back my starting point, right? So let me show how that works. So let's say in this case I had started, okay, so let me draw that up so that it's easier for you to visualize. Or let's just clean this up. Okay, cool. Let me pick my car up again. So let's say instead of starting at index 3, we started at index 4. Then what would have happened? Cool, let's try that out. So at index 4, I would have said that I have 5 units of gas and I just need 2 units of gas to travel to the next index. Can I do that? Definitely yes. So pick my car up, bring it over here, right? The amount of fuel now you have is 5 minus 3, that is equal to 5 minus 2, that is equal to 3. And you can also add 1 more unit of gas from the 0th location. So you now have 4 units of gas. What's the amount you require to travel to the next gas station or to the next station? It's 3 units. Can you spin that? Yes, I can spin that. So okay, 4 minus 3 is equal to 1. Now you have 1 unit left and you can travel to the next station. Cool, I'll travel to the next station. I can fill it up with 2 units more, right? So 1 plus 2 is equal to 3. Now to travel to the next station, I need 4 units of gas, right? But wait, I just have 3 units of gas, so I can't do that. So what should I do? Now I'll assume that I didn't start at 5 actually. Let's say I started at 4. That's what I assume. I'll just assume that I started at a previous point. Had I done that, so what would have happened? I would have been able to get extra fuel of 4 units had I started this, and I would have incurred extra loss of 1 unit, because in order to go from this unit to this unit, or from this point to this point, I would have required 1 unit of fuel. So in totality, I would have gained 3 units of fuel. So if adding 3 units of fuel works for me, well and good. Otherwise, we'll keep traversing back and back. As simple as that. I hope that absolutely made sense. So let's say our requirement wasn't fulfilled over here. So then we would have gone back one more until unless our requirement would have been fulfilled. So that's about it. So that means we can pick up any point, or any point as a starting point, right? So what point should we pick? So now technically anything would be valid. So even if you're picking the most strongest point, so let's say the point you should have picked was 0 and you're picking n, it still would be valid, right? Because when it won't make sense, you'll have to traverse back and eventually you'll land at point 0. That would make sense then. But which point would make the most sense? Now what I'll say is that the point that would make the most sense is actually n, or the last index itself. Now why is that the case? Because when we're trying to traverse back, right, what would happen is that, let's say you are, so in no circumstance would we have to come from here to here, because we are starting at n-1 itself. So even in the worst possibility, you'll only have to traverse back over here, else the answer wouldn't exist, right? So if we are just going in this fashion, you don't have to take care of negative values or modding it up, because once you have to move in the circular direction, you have to take care of modding it up as well, right? And the benefit of using this approach is that I can, if I'm starting from here, I can say that currently I'm at this particular index, because that is the index I've already started at. So I'll be currently at this. I hope that makes sense. Now let's try to code it up. Great. So what I'll say is, okay, let n equal to gas dot size. So that's the size of my arrays that I'm having. Then I'll say my current gas, or current gas, is equal to 0. Let's give it the value gas I, gas n-1 rather. Now I'll have to go till the time. Okay, so let's give it a start point. So as I said that the start point is n-1 and the end point would be 0. So while start, now start is to the left, to the right of end, so start should be greater than equal to end. As soon as start is equal to end, that means we have completed our loop and we can return 1 from here itself. Also, what's the case that we want to avoid? Like, when would it be negative? So it would be negative when the gas, in totality, the gas you're going to consume, or the gas you actually have, is less than the total cost, right? So we can do a simple check over here. If accumulate, so accumulate is a STL function, so it basically sums up the values that you provided. So sum up all the values that are there in gas, right? 0 LL. If it's less than the values, the value of cost dot begin cost dot end, then in that case simply return me -1, because in this case the total amount of gas you are having is actually less than the cost, so there's no way you're going to complete this journey. So yeah, we have made that check over here. Then what we can say is, if we reached over here, then I have to move from from the start to the end, right? Or from this position to this position. So let me do one more thing. Let's take it over here. This would make, okay, sorry. Okay, let's say end car gas is equal to whatever I was able to attain at n-1, or the starting location. That makes sense, I guess, right? Minus the, okay, so it's not start of start but gas of start, minus whatever I required to go to the next point. Perfect. We can even start it with 0 if you start it with 0 if you want, but let's go it with this only. Cool. Now eventually when we'll do this, so that would mean that the end of the array is traversed, so our car would complete that particular clockwise clockwise motion and would come at the 0th position. So end is already 0 over here. So in this loop what I'll say is that while if my car gas is less than 0, so that would mean my assumptions were incorrect and the selection of the starting point was incorrect. in that case I'll have to shift my starting point at a previous location, so start minus minus. Also when I'll do that, so I'll have to change my cur gas. So cur gas would now have added cur gas start minus whatever would be the cost of moving from the ith index to the I+1 index. So I think this also makes sense. Not over here but over here. I hope this made sense. After that what we can say is, okay, I messed up a column. Yeah, now I'm starting at the like at this particular index. So if I want to go forward, what I have to do, so the only thing I need to do is that gas or cur gas end cur gas plus equal to gas of end, because I can have this gas and then also I'll have to spend some gas so as to go to the next location. So minus end, and then I can say end plus plus. Let's try this up. Okay, so this gives some error. Let's see why. Okay, okay, so that's a typo actually. No, this should work. Great, I'm getting a wrong answer, but oh, I'm returning one. Actually I have to return the start. Still getting a wrong answer. I'm getting the answer as 4, wherein the answer should have been 3. Now why is that the case? Subtracting the cost, that is what we should do. I'm only doing it when all of this makes sense actually. So here's the issue. Oh, I'm actually subtracting the same thing. Oh, so just be like safe of these kind of typos. They can actually mess you up. So whenever you face some difficulties, like just verify that your algorithm is correct and then look for such kind of typos in the solution. So yeah, this works, and the algorithm is quite simple as well. So what would be the complexity of this? So the time complexity would be order of n. The space complexity is order of 1. We didn't use any other space other than the constant space we've used over here. So I guess you like the explanation, you understood the concept well. If you have any doubts, let me know in the comment section below. Thanks a lot guys.